Here's today's question, which is worth 30 marks. We're given a description of a triangle that has one side of length 10 centimeters and another side of length x centimeters. Also, the total perimeter of this triangle is 26 centimeters. In part A, we're given two diagrams of such triangles and we have to find the length of the third side in each case. Starting with diagram A, to find the length of the third side, we take the length of the other two sides away from 26, which leaves us with 12 centimeters. Moving on to diagram B, we do the same thing. In this case, the length of the third side is 7 centimeters. Moving on to part B, we have to find three values of x that would make this triangle an isosceles triangle. There's no formula to find this answer, so the only way to find an answer is by trial and error and just running through examples in your head. Remember that the perimeter must be 26 centimeters. The first possibility for this is if the base is 10, the side x is 10, and the other side is 6. So since x is 10 in this case, that's what we write into the box. Another possibility is that we keep the base at 10 and both other sides are 8 centimeters. In this case, x is 8 centimeters. Finally, the last possibility is just the reverse of the first one. I wouldn't blame you if you had trouble finding this answer, because it can be quite head-wrecking going through all the examples in your head, and you might not think of this solution. In this case, x is 6 centimeters and the other two sides are 10 centimeters. And that's all we have to do for part B. In part C, we're given a graph showing the area of the triangle for all values of x, and in part 1, we're given a point A, which is at x equals 4 centimeters, and we have to find the area of the triangle in this case. So what we do here is draw a horizontal line from A to the y-axis, and then read off the value from the y-axis, which in this case is between 18 and 19, so the area is about 18.6 centimeters squared. In part 2, we have to plot the point B on the graph to represent the triangle in diagram B from part A of this question. Recall that in diagram B, x is equal to 9 centimeters. So what we do in this case is come across to 9 centimeters on the x-axis and draw a vertical line up till we hit the curve. Where this line touches the curve is the point B. In part 3, we have to draw the axis of symmetry of this graph and write down its equation. One way you can do this is by simply looking at the curve and seeing where it turns around at the highest point, and then drawing a vertical line straight down from this. Another way to think of it is by looking at the x-axis and realizing that the difference between 3 and 13 centimeters is 10 centimeters, so the axis of symmetry would be halfway between this, which is 5 centimeters either side, which gives us 8 centimeters. So the axis of symmetry is the vertical line at 8 centimeters. The equation of the axis in this case is x is equal to 8, since the x value is constant. In part D, we're told that when x is 5, the triangle has side lengths of 10 centimeters, 5 centimeters, and 11 centimeters. We have to show that this triangle is not right angled. There's a trick to this question which involves using Pythagoras' theorem. In the case that this is a right angled triangle, then Pythagoras' theorem would work in this case. Since 11 centimeters is the longest side, this would act as the hypotenuse. So in that case we get this equation. Squaring all these numbers and then adding them together, we get 125 is equal to 121, which is clearly not true. So therefore this triangle does not obey Pythagoras' theorem, and therefore it's not a right angled triangle. In part E, we're given one of these triangles and told to work out the area of it. Since the area of a triangle is half times the base times the height, we must know the height of this triangle to work out the area. To do this, we can split the base in half, giving us two triangles of base 5 centimeters. Now we can label the height h and solve it using Pythagoras' theorem. Plugging these numbers into the formula, we eventually work out h to be equal to root 39. Therefore the area is equal to 1/2 times the base, which is 10 centimeters, times the height, which is root 39, which works out to be 5 root 39 centimeters squared. And that's the end of this question. I hope you guys found this solution video helpful. Thanks for watching, and I'll see you guys again.